Hello, ladies and gentlemen. I am Rushdie Brahim Jasim. I am teacher at Mustansariya University College of Education, Physics Department, Baghdad, Iraq. Today, I'm going to talk about the effect of annealing temperatures on the properties of CdS double aluminum on copper Schottky diode. Cadmium sulfide divided by aluminum has been prepared successfully by chemical bath, then deposited on glass and copper substrates by the bar coating method and annealed at room temperature 150, 200 and 250 Celsius degree. X-ray diffraction show that structure of films is polycrystalline with hexagonal artistic structure, and there are strong peak in plane 002. AAPM was used to study the topography of film and showed that annealing makes the surface of the films smoother. Current voltage characteristic of the film Schottky diode showed that forward and reverse biases have symmetric behavior with applied voltage. The differences between forward and reverse current with applied voltage indicated that junction has high rectification characteristic. The value of saturation current J/S, high barrel height, and rectification factor RF of junction and the effect of annealing temperature on it were studied. Films was prepared by CdS double aluminum from aqueous solution of following material were prepared 4 milliliter of 0.1 molar cadmium chloride CdS.Al and 8 mole of NH3 solution, 4 milliliter of 0.02 molar sodium hydroxide NaOH, 5 ml of 0.05 molar thiourea, and 4 milliliter of 0.05 molar aluminum chloride. Then use the bar coating method to deposit the CdS double aluminum films on a glass substrate, X-ray diffraction and AAPM, and deposit on copper substrate to fabricate Schottky diode. The prepared films were annealed at 500, 200 and 300 Celsius degree. To confirm the structural properties of the symbol, the atomic force microscopy was used to analyze the topography of symbol. After adding silver-based electrodes to each side of the film's junction, voltage current test was performed at the forward and reverse biases. Figure 1 show atomic force microscopy image of CdS double aluminum films under different annealed temperatures. It was noticed that the samples that were not annealed had a relatively rough surface that contained many portions, but after annealing these portions this protrusion began to decrease and the surface became less rough This figure on table 1 shows that the value of surface roughness, grain size, and root mean square increases clearly with the increasing in the annealed temperatures. This is due to that the fact on annealing on the films CdS double aluminum films leads to the neighboring particles becomes more strictly connected as the vacant areas among the grains are filled up by the relative either spiral of practice in the film. Figure 2 show that the X-ray diffraction pattern of as deposited and annealed CdS double aluminum films. From figure, it is clear that all prepared film have polycrystalline structure with oriented along 002. Figure 2 it shows that this film has hexagonal orthotized structure. The density of peak and crystal size was calculated using the Scherer equation and show increasing annealing temperature as shown in table 1. This indicates that the crystal structure of film improved with annealing. Figure 3 shows the change in the peak current as function of the basis voltage applied to the two ends of the heterojunction CdS double aluminum on copper. In the case of forward and reverse bias, when bias voltage from 0 to 1.6 volt is applied, it has been observed that the dark current behavior function is non-linear and most likely exponential. The non-linear behavior can be attributed to the possibility of free charge carriers being captured by impurities. By increasing the voltage applied to the both ends of junction, the drift speed of free carriers increases, and thus the transit time of carriers is short, which reduces the catching or sniping of the free carrier and thus obtains a higher current. When the annealing is performed, the dark current values increase clearly as seen in figure 3. On the other hand, it was observed that the forward bias current and the rectification factor RF increased significantly with increasing annealing temperature as table 1. Depending on figure 4, it was found that the saturation current increases with the annealing temperature while the barrel height has decreasing behavior with the annealing temperature. This is attributed to an increase in the crystalline grain size as in X-ray diffraction measurement. Also, the current increases slightly with increasing annealing temperature because the increasing of annealing temperature will causes arrangement the interface atoms and reduce the dangling bonds, which led to improve the junction characteristic. The barrel height value and the effect of annealing temperature on 8 are listed in Table 1. In conclusion, from the research is that the films, CdS double aluminum on copper Schottky diode can be successfully prepared using the bar coating method, where the symmetric behavior of current at forward and reverse biases the annealing temperature, improves the topography, structure, and electric properties of the film diode by making the surface smoother and increasing the crystalline state, as well as increasing both the rectification factor, saturation current, and decreasing the barrier height value. Thanks.